Hello everyone. So welcome to the fourth session on piecewise smooth curves and line integrals. So this is a continuation to my previous session. In the previous session I missed out on how to deal with the curves which are piecewise smooth. So we saw that if the curve is overall a smooth curve, then we saw how to do the line integral. But if you have the piecewise means what? If you see this curve, so from -1 to 1 it's a straight segment, so it's a smooth curve, means it's a differentiable function. But here if you see from here to here it's a arc of a circle, and here you can see there is a sharp point. So and here also from here to here it is a straight line, so here also it's a sharp point. So these are the points for this complete curve. So at this point the function is not a differentiable function, so it's not a smooth curve. So if you have this curve which are smooth piecewise, so then in that case how to do the line integral. So now my curve is what? It is C1 union C2 union C3. So if I do the and what is my curve? My curve is the union of these three curves, and if I do the line integral over this union, then question is what is the line integral? And answer is very easy. I mean, line integral behaves in a very nice way, and the answer is, when you have such a scenario, then line integral over this curve is nothing but you do the line integral over C1 plus you do the line integral over C2 plus you do the line integral over C3. So you do individually and then you add them up. What you get is the line integral over the whole curve. So that's how you solve such kind of problems. Whenever you have a piecewise smooth curve, you just split them up into the pieces. Wherever it is smooth, you parameterize and your job is over. So let's complete this problem so that you will have a better picture. So let's go first along the curve C1. So if I want to go along the curve C1, so I will parameterize this curve. So this is nothing but, this is a very nice one. This is nothing but the part of the x-axis. So my y component is 0 and let x equal to t. So what is the range of t? -1 less equal t less equal 1. So this is the parameterization of a segment. So when my t is -1, what is the point? -1 comma 0. And when t is 1, the point is 1 comma 0. So this is the parameterization for this curve. And once we have the parameterization, you find r dash of t, you find f of r of t. What was my f? What was my vector field? My vector field was y comma x. Actually, if you know the vector field, is well and good. In this case, the vector field will go outside, like this will be the vector fields. If you know the vector field, it's well and good. So this is the vector field and this is the curve. So like, if you know the vector field, you can visualize these things in more nicer way. But anyways, my job is to make sure that you should be able to solve the problem. But make sure you should be able to plot the vector fields. So this was my vector field. So what is my f of r of t? It will be wherever you have x, we put t, wherever we put 0. So this is 0 comma t. So what is f of r of t into r dash of t? When I take the dot product, this is 0. So line integral along C1 is nothing but 0. Now we do the line integral for C2. What is C2? It is the arc of a curve or arc of a circle. Which circle? Unit circle. So I know we saw in our session on parameterization. How do we parameterize the circle? Since the radius is 1, it is cos t comma sin t. And since the arc is in the first quadrant, so t is from 0 to pi by 2. When my t is 0, I get the point 1 comma 0, and when my t is pi by 2, I get the point 0 comma 1. And yeah, that's all. Now your job is over. Now you simply take the derivative, minus sin t comma cos t. You find f of r of t, which is nothing but, it was y comma x, so it is nothing but sin t comma cos t. And if you take the dot product, f of r of t dot product with r dash of t, it is nothing but minus sin square t plus cos square t. And now you simply have to integrate this. So if I integrate from 0 to pi by 2, minus sin square t plus cos square t. Now this integration is easy to solve, I hope. You have to use double angle formula. What is sin square t? It is 1 minus cos 2t by 2. And what is cos square t? It is 1 plus cos 2t by 2. And then you simply integrate, you get the answer. So we solved this along C2 as well. And what is the last thing? The last thing is we need to solve along the curve C3. Okay, now so let's go for the third curve. So what is the third curve? The third curve is nothing but a segment joining 0, 1 and minus 1, 0. So this is the segment which I need to parameterize now. So you know how to parameterize a line segment, which we saw in our second session on parameterization. It is nothing but 1 minus t into a plus t into b, where a and b are nothing but the line joining the points a and b. That is one way which you can try, but otherwise if you see, there is nothing but equation, is nothing but the line passing through 0, 1 and minus 1, 0. So y is nothing but x plus 1. This is nothing but the equation of line. As you can see, when my x is 0, my y is 1, and when my y is 0, my x is minus 1. So this is nothing, this line is nothing but this one. So when I take x equal to t, my y will be t plus 1. So therefore this is what the parameterization of the curve is. It is nothing but t comma t plus 1. Okay, so now what is the range of t? My range of t will be, so my first point should be 0 because this is the orientation. So the first point should be 0. So when my t is 0, I am having 0, 1, and when my t is minus 1, I am having minus 1, 0. So that's the point where one has to be careful. Many times people just write t from 0 to 1, but that's wrong. If you want t from 0 to 1, use that parameterization which we did in our second session. And if you go by that way, then the parameterization will be 0 to minus 1. Okay, so if I take this as a parameterization, then what is my r dash of t? It is nothing but 1, 1. And what is f of r of t? It is nothing but t plus 1, t. And if I take the dot product, f of r of t, dot product with r dash of t, it is nothing but t plus 1 plus t, which is nothing but 2t plus 1. So what is the line integral? T is going from 0 to minus 1. 2t plus 1 dt. You solve this integral, which is very easy, and you get the line integral along the curve C3. And since now I have all the three line integrals, and if my curve C is the union of these three curves, then the line integral is nothing but addition of all these three line integrals. So that's how you solve the problems which are piecewise continuous. Let's take one more example, and then I will stop. So if I take, suppose if I take y equal to x square and y equal to x. So 0, this is my curve C1, this will be 1, 1, and this is my curve C2. So what is my curve? My C is nothing but C1 union C2. So that is what my curve is. So I want to do the line integral over the curve C. So since it's piecewise smooth, because at 1, 1 is not differentiable, so I will do the line integral along the curve C1, and then I will do the line integral along the curve C2. So let's go one by one. So if I want to do along the curve C1, what is r of t? So it is nothing but y equal to x square. So when my x is t, my y is nothing but t square. 0 less equal t less equal 1. I will have some vector field. Suppose my vector field is nothing but minus y comma minus x. I am taking the simple vector field so that the calculations becomes easier. So if this is my vector field, and for C1 curve, this is a parameterization. So r dash of t is nothing but 1, 2t. You find f of r of t, which is nothing but minus t square comma minus t, because minus of y comma minus of x. And when I take the dot product, it is nothing but minus t square minus 2t square, which is minus 3t square. And when I integrate f dot dr over the curve C1 is nothing but integration of this from 0 to 1, and this will come out to be minus 1, provided my calculations are correct. So this is what the answer is for the curve along line integral along the curve C1. Now we do the same thing for curve C2. I won't solve completely, I will only give you the parameterization because the integral is easy. So if I want to do along the curve C2, how will I do along the curve C2? It is nothing but a line. What is the line? Y equal to x. So what is my r of t? It is, if I put x equal to t, my y will also be t, because the line is y comma x. Many times people in a hurry, they do 0 less equal t less equal 1, which is wrong. That is not the case. Why? Because my starting point is nothing but 1, 1. I am going from 1, 1 to 0, 0. So this is my orientation. So instead of going from 0 to 1, what is my t? T will go from 1 to 0. Because when my t is 1, the first point is 1, 1, and the last point is 0, 0. So that's usually the mistake people do. So yeah, that is my r of t. So now what is my r dash of t? It is nothing but 1, 1. And when I take f of r of t. What is f of r of t? My vector field was minus y comma minus x. It is minus t comma minus t. So f of r of t dot r dash of t is nothing but minus 2t. And when you do the line integral, your answer will again come out to be minus 1. And when you sum it up, your answer is minus 2. So that's how you solve the problems on piecewise continuous curves. So see the pieces, parameterize the pieces, and do the line integral. And then the line integral of the whole curve is nothing but line integral of the individual curves, sum of the line integral of the individual curves. So let me give you one final homework, and for practice you can try this question. So if I give you f, my vector field to be say y square comma x square, and suppose if my parameterization is nothing but r of t equal to 1 for minus 1 less equal t less equal 0, and suppose t square plus 1 less equal t less equal 1. So one can see that this is a parameterized curve, and okay, let me draw the curve. So what is the curve? From minus 1 to 0, function is what? 1. This is my C1. And from 0 to 1, what is the curve? This is my 2. So this is my C2. So C2 is from here to here, and C1 is from here to here. Because y square plus 1 is nothing but the parabola x square plus 1, right? So my r of t is x square, means y is x square plus 1. In that way if you go, so it is nothing but a parabola. So C2 is a part of a parabola y equal to x square plus 1, and C1 is nothing but the constant function 1. So you do along C1, you do along C2, you just add them up, you get the line integral along the union. So yeah, I mean, it will be good if one of you can just put the answer in the comment section so that others can verify. And if you have any other doubts, then you can ask me in the comment section. Thank you.